Hello, everyone. Today we're going to be looking at interpreting the unit rate as the slope of a line. So for number one, it says Judy can decorate 18 cakes in 6 hours. Which graph has the slope that best represents the number of cakes per hour that Judy can decorate? So the first thing I look at in my problem, it says 18 cakes in 6 hours. Which graph has the slope that best represents the number of cakes per hour that Judy can decorate? So what I'm going to do is I'm going to look at my two graphs my four graphs, and the first thing I notice is that my y-axis says number of cakes and my x-axis says time in hours, and it says that for all of them. So the information that I'm given is 18 cakes in 6 hours. And one way that I could work this problem is go through my graphs and see where I have 18 cakes in 6 hours and they match. Okay, so that's what I'm going to do first. And then to verify our answer, we're going to make a table and see if it does match exactly. So 18 cakes in 6 hours. So when I go over to 6 hours, I should be able to go up to 18 cakes and my graph should be going through that. And here on answer choice A, it does not go through that. So A won't be my answer. So for B, again, I'm going to go over to 6 hours and I should go up to 18 cakes. And I should have my graph going through that point, but it does not for B. So B is not my answer. So over here for C, when I go over to 6 hours and up, I do match up with 18 cakes. So C is a possibility, but I'm going to come back and double check just to make sure. And then D, when I go over to 6, if I go up, it does not match up with 18 cakes, so D is not my answer. Now, if I did have another graph that matched at 6 and 18, then I'm going to make a table, and that's how I would check this problem. So I noticed at the beginning that my time was my x's and my cakes was on my y's. And we said that 6 hours is 18 cakes. All right, and then it said cakes per hour. And per hour is talking about 1 hour. Okay, so 18 cakes in 6 hours. If I wanted to know 1 hour, then I could do 18 divided by 6. And so when I do 18 divided by 6, I get 3. So that's telling me that in 1 hour, Judy can make 6 cakes. So if I go off this information, I know that in 2 hours, 3 would double because my hours doubled. So 3 would become 6. So that in 3 hours, I would increase by another 3 cakes and get 9. So then I have 4 hours and 5 hours. And if I keep increasing my y's by 3 and my hours by 1 hour, then I would get 9 goes to 12, and then 12 plus 3 would be 15. So I've made a table with my points, and when I look, I can see 1 hour does equal 3 cakes, 2 hours does equal 6 cakes, 3 hours does equal 9 cakes, 4 hours does equal 12 cakes, and 5 hours does equal 15 cakes. So C is in fact my answer for this problem. Okay, so we're going to move on to example 2 now. So example 2 says, based on the graph shown, which statement best describes the rate of change for this situation? And one thing that we need to remember is that rate of change is another word for slope. Okay. And when I look at my answer choices, I'm just going to read through them to start. It says Joseph runs 1 lap per minute. Okay. B says Joseph runs 6 laps per minute. C says Joseph runs 0 laps per minute. And D says Joseph runs 5 laps per minute. And just like in our first example, we said that per hour meant in 1 hour. So for us, per minute is telling us in 1 minute, okay? Now that does help us because if we look at our graph, our time or our minutes is on our x-axis. So if I go over to 1 minute and I go up, I can see that Joseph runs 1 lap in 6, or in, sorry, let's rewind that. In 1 minute, Joseph runs 6 laps, okay? So 1 lap, no, we just said it was 6. B, 6 laps, yes. D said 0. No, we can clearly see he's running. And 5 is a little too low. It does not match there. So B is going to be my answer for number 2. All right. So now we're going to talk about slope and y-intercept from a table or a graph. All right. So example 1 A says find the slope and y-intercept of each problem. Okay, so a couple things we need to remember. When we are finding slope and we have a graph, we're going to use rise over run. So we're going to count how many spaces we go up and how many spaces we go over until we get to another coordinate. And on our graph here, it does give us 2 points to look at to count our rise and run. So I'm just going to start by drawing a right triangle, connecting those 2 dots so that I know how many spaces I need to count up and how many over. All right. So to count, I would just 1, 2, 3, 4, 5, 6, 7. And those 7, I went in the up direction. So because I'm going up, those are positive numbers on our y-axis. So I'm going to put plus 7. And then to count my run, I'm going to count 1, 2, 3, 4. And I did that 4 to the left. And when I look at my x-axis, when I go to the left, those are negative numbers. So that'll be a -4. So to make my fraction, my rise will be plus 7 and my run will be -4. And when we have a graph, I do like to see your slope stay as a fraction because that's easier to tell how many I'm going up and how many I'm going over instead of when we turn it into a decimal. The only thing I'm going to do, I'm going to rewrite it and I'm going to put this negative sign in front of the whole number. So I'm just going to put -7/4 as my slope. Okay. Now another thing, right away when I saw the graph, I could tell that it's negative because if I look at the graph like we read from left to right, I could tell that the graph is going down. So that also is a way to help me eliminate answer choices because I can see the direction the graph is going, all right? So that was slope from a graph. The next thing we're gonna do is we're gonna find our y-intercept. And when we have a graph, or our y-intercept is where the graph crosses the y-axis. Where graph crosses the y-axis. Okay. So what I like to do is I like to get a highlighter and just highlight my y-axis. And the reason I do that is it helps that y-axis stick out and it makes it a little easier for me to see where my graph is crossing through that. And I can see there is a point right here. So my y-intercept is at the coordinate 0, +3. Okay. So that's my y-intercept. And it is a positive 3 because that's the coordinate that it's crossing at. So now we're going to try example B. So just like I started with on A, I'm going to draw that right triangle connecting my points. That's going to help me know how much to count when I do this problem. So again, slope is my rise over run. So when I count how much I go up, I'm going 1, 2, 3, 4. And I went in the up direction, so that's going to be a positive 4. And then when I count my run, I'm going over 1, 2. And these two, I went towards the right, which are positive. So that'll be a positive 2. Okay. Now I can simplify my fraction 4 over 2. If I typed 4 divided by 2 in the calculator, that would give me 2 as my slope, right? And now we're going to do our y-intercept. So we're going to see where our graph crosses the y-axis. So just like on A, I'm going to go ahead and highlight my y-axis to make it stand out where the graph is crossing. And on this one, I can see that my graph crosses at this point here, which is at -1, -2, -3. So it is at 0, -3. All right. So besides seeing these problems as slope and y-intercept, we could also see them as the letters that they represent in slope-intercept form. And slope is represented by the letter B in that equation. I'm sorry. No, it is not. Whoa, I don't know what's going on with me this morning. Slope is represented by the letter M. And our y-intercept is the one that's represented by the letter B. All right, much better. Okay. So now that we've found slope and y-intercept from a graph, we're going to go ahead and find slope and y-intercept from a table. Okay, now it is a little different when we have a table because for slope, we can't just count our rise and our run because I can't sit here and graph out all the way to 80. Okay, so when we have a table, we need to do our change in y, and that little triangle means change in, over our change in x. And what that means is we need to look at our y column or row of the table and see how it changes. So and I can pick any two coordinates. I'm going to go ahead and just pick the top two. Okay, again, I could pick the bottom two, I could pick the middle two, doesn't matter. I'm just going to look at the top two. So when I see how I changed from 80 to 70, I notice and I know that I subtracted 10 because 80 minus 10 does equal 70. So now I'm going to find my change in x, and to go from a -2 to a -1, I know that I added 1 there. So -2 plus 1 gives me -1. And I'm going to use those numbers to make my slope. So change in y, here's my y's. I did -10. And then change in x, I did +1. So when I type that into my calculator to simplify that, I would get a slope of -10 for this problem. All right. So on a table, to find our y-intercept, If we can see here, we said our y-intercept is where the graph crosses the y-axis. And that gave us the coordinate 0 and then our number for both problems, okay? So we wrote it that way specifically because that means when I'm looking at a table, I'm looking for when my x is 0. And whatever number is in my y for that, when x is 0, that is what my y-intercept is going to be. So I'm just going to look at my x's until I see 0. -2, -1, 0. That's what I need. So my y-intercept is 0, 60. All right. So if I look at my table, this one was easy because 0 was in my x column, but that's not always going to happen for us. And if we look at example D, we don't have 0 there. So we're going to go ahead and work example D to see how to do this. Now, starting with our slope, we are going to use our same little formula, change in y over change in x. And we are going to pick 2 points, just like I picked the top 2 here. We're going to pick 2 on this table. Now, the 2 that I'm going to pick on table D, I'm actually going to pick the bottom 2. And the reason I'm doing that is because those are all positive numbers. And personally, I prefer positive numbers, so that's why I'm picking those 2. I'm going to get the same slope no matter which data points I pick, as long as they're consecutive or as long as they're in a row. Okay, so change in y, here's my y's. To go from 0.5 to 1.5, I added 1. And then when I look at my x's, to go from 3 to 5, 3 plus 2 gives me 5. So for this fraction, I have y, which is plus 1, divided by x, which is plus 2, or not, sorry, let me rephrase that. Change in y, which was plus 1, divided by change in x, which is plus 2. And I'm going to just leave that in a fraction as 0.5. As 1.5. And now I'm going to find my y-intercept. So when we looked at the first table, we were able to find 0 in my x column. I don't have it here in my x column on this table, but I know that. Good morning, Alvin. All right. So when I look at my table, I know that 0 would go right here in between -1 and 1. Okay. So what I'm going to do is I'm going to rewrite this portion of my graph so I can put the y-intercept on my table. So x, y, -1 was at -1.5. Then we're going to put 0 there, and I don't know what my y is, but I know that 1 is at -0.5. Okay. Now, when we were finding our slope, when our x's increased by 2, our y's increased by 1. But when I look at this new portion that we made, to find 0, our x's are not going to increase by 2. To go from -1 to 0, they're going to increase by 1. Okay. So then when I'm finding my change in y, I notice that 1 is half of 2. So instead of increasing by 1, I'm going to increase by half of that, or 0.5. So -1.5 plus 0.5, that would give me -1. So now in my table, I do have 0 in my x column. So my y-intercept would be 0, -1. Thank you for watching. Please make sure your notes are completely filled out like mine are. You can rewind the video if you need to. Have a good day.